What's going on, everybody? Welcome back to my YouTube channel. We have a very nice and beautiful question on the board that we're going to be solving. And the question says, find the values of x if x over 2 times x over 2 times x over 2 is equal to 2 over x times 2 over x times 2 over x. Well, our first step will be for us to multiply the numerator. So x times x times x gives x cubed all over. Now the denominator, 2 times 2 times 2. This is 2 cubed. And this is equal to, now on the right hand side, 2 times 2 times 2. That's 2 cubes. All over. Now x times x times x, that's x cubed. Very good. Now our next step will be for us to cross multiply. So let's cross multiply. So this is x cubed times x cubed. This is equal to 2 cubes times 2 cubes. Very good. Now, according to indices, when I have, for example, a to the m times a to the n, this is the same as a to the m plus n. So we're going to be applying the law of indices to what we have on the left and on the right. So on the left, this becomes x to the 3 plus 3. This is equal to, on the right, this becomes 2 to the 3 plus 3. Very good. So this results to x to the 3 plus 3, that's 6. This is equal to 2 to the 3 plus 3, that's 6. Very good. Now our next step will be for us to move 2 to the 6 to the left hand side. So we have x to the 6. As 2 to the 6 crosses to the left, it becomes minus 2 to the 6. And this is equal to 0. And if we have to simplify this further, we have x to the 6 is same as 3 times 2. Minus, this is 2. 6 is same as 3 times 2. And this is equal to 0. And from indices, when I have, for example, a to the m times n, this is same as a to the m and raised to the n. So we're going to be writing this and this in this form. So this can be x to the 3 raised to the power of 2 minus, this is 2 to the 3 raised to the power of 2. And this is equal to 0. Now notice that we have difference of 2 squares. And difference of 2 squares, there is a property which says when I have a squared minus b squared, this is equal to a minus b times a plus b. Very good. So we're going to be writing this in this form. So this can be x cubed minus 2 cubes times x cubed plus 2 cubes. And this is equal to 0. So we've been able to express this difference of 2 squares in this form to get this. Now we have 2 cases, for case 1. So I'm going to be writing case 1. This is the first case, which is x cubed minus 2 cubed is equal to 0. Or for case 2, so case 2, we have this, which is x cubed plus 2 cubes is equal to 0. Now we're going to be solving these cases one after the other. So let's say for case 1. So for case 1, we have x cubed minus 2 cubes to be equal to 0. You know, actually, this is difference of 2 cubes. And for difference of 2 cubes, when I have, for example, a cubed minus b cubed, this is equal to a minus b times a squared plus ab plus b squared. Very good. So let's write this in this form. So this can be x minus 2 times x squared plus 2x plus 2 squared. Very good. And this is equal to 0. So we've been able to write this in the form of difference of 2 cubes, just like this. Now we have 2 cases, but before that, let's simplify what we have here. So this is x minus 2 times x squared plus 2x plus, now 2 squared is 4, and this is equal to 0. So there are actually 2 cases from here. The first case is where we have x minus 2 to be equal to 0. And for the second case, that's what we have x squared plus 2x plus 4 to be equal to 0. Now, it is very easy for us to get the value of x from the first case by moving negative 2 to the right-hand side. So x is equal to, now when I move negative 2 to the right-hand side, it becomes positive 2. And this is a real solution for x. So this is the first value for x that we've got. Now, moving to the second case, you notice that we have a quadratic equation. Now, let's use the quadratic formula to solve this question. We're looking for x, so x is equal to negative b. I'm writing down the quadratic formula, plus or minus the square root of b squared minus 4ac all over 2a. Now, what is our a, what is our b, and what is our c? Our a is a coefficient of x squared, and that's 1. So I'm going to be writing 1 here. Our b is a coefficient of x, and that's 2. And our c is a constant term, which is 4. So let's substitute into this quadratic equation. So x is now equal to negative b. And what is b? b is 2 plus or minus the square root of b squared, that's 2 squared, minus 4ac. So 4 times a is 1, and c is 4, all over 2a. Wow, this is Ben, so let me do it very well. So all over 2a, which is 2 times 1, since a is 1. So x now becomes negative 2 plus or minus the square root of b squared, that's 2 squared is 4, minus 4 times 1 times 4, that's 16, all over 2 times 1 is 2. So this simplifies into x equal to negative 2 plus or minus the square root of 4 minus 16 is negative 12, all over 2. Now, let's simplify this negative 12. So we have x to be equal to negative 2 plus or minus the square root of, I'll be splitting negative 12 into 4 times 3. So 4 times 3 is 12, and then times negative 1, which results to negative 12, all over 2. So this expression is same as we have x equal to negative 2 plus or minus. Now I'm going to be separating this into the square root of 4 times square root of 3 times the square root of -1. Very good. All over 2. So x now becomes -2 plus or minus. The square root of 4 is 2. So 2 times the square root of 3. So times the square root of 3 times the square root of -1. The square root of -1 is actually iota. All over 2. Now notice that 2 is common on the numerator. So we're going to be factoring out 2. So x equal to factor 2 out. Now -2 divided by 2, that's -1, plus or minus 2 root 3i divided by 2, we have root 3i all over 2. Now 2 cancels out 2, so we have x to be equal to -1 plus or minus the square root of 3i. So there are actually two values of x from here. So we have the first one. Okay, we've already got the first one. This should be the second one to be equal to -1 plus, which is taking the positive side, the square root of 3 times I. Or the third one, this is equal to -1. Now this time, go with the negative minus the square root of 3 times I. So we've been able to find 3 values of x from our first case. Now let's move on to our second case. So we call case 2. So for case 2, remember that we have x cubed plus 2 cubes to be equal to 0. Now notice that we have the sum of 2 cubes. And the sum of 2 cubes has property of a cube plus a cube. This is equal to a plus b times a squared. Okay, this is supposed to be minus, so minus ab plus b squared. So this is a property of the sum of 2 cubes. So this expression can be written in this form as x plus 2 times x squared minus 2x and then plus 2 squared. Very good. And this is equal to 0. So simplifying what we have inside of this bracket, we have x plus 2 times x squared minus 2x plus 4 squared is 4. And this is equal to 0. So we have two cases from here. The first case is x plus 2 equal to 0. And the second case is what we have here, which is x squared minus 2x plus 4 equal to 0. So the first case is easy for us to find. So x will be equal to, moving plus 2 to the right hand side, we have minus 2. Now we're going to be solving the second case using the quadratic formula, since we have a quadratic equation. So using the quadratic formula, we're looking for x. So the quadratic formula is x equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Now what is our a, what is our b, and what is our c? Our a is a coefficient of x squared, and that's 1. And our b is a coefficient of x, and that's -2. And our c is a constant term, which is 4. Now let's substitute into this quadratic formula. We have x to be equal to -b. What is b? b is negative 2, so negative 2 plus or minus the square root of b squared. B is negative 2, so I'm going to be putting negative 2 squared minus 4 times a. What is a? A is 1 times c. What is c? C is 4, so times 4 all over 2 times a. That's 2 times a is 1. Very good. So x is now equal to negative times negative gives positive. So I'm going to be having 2, positive 2, plus or minus the square root of. Now, negative 2 squared is 4. Minus 4 times 1 times 4 is 16. All over 2 times 1 is 2. So this simplifies into x equal to 2 plus or minus the square root of 4 minus 16 is negative 12 all over 2, making x to be equal to 2 plus or minus. Remember what we did? We have to split the negative 12 into 4 times 3 times negative 1 all over 2. So x now becomes 2 plus or minus. Remember what we did by separating each of these terms. So we have the square root of 4 times the square root of 3 times the square root of negative 1 all over 2. So x now becomes 2 plus or minus the square root of 4 is 2 times the square root of 3, so times root 3. Now the square root of negative 1 is iota, which is I, all over 2. And now factoring out 2 from the numerator, we have x to be equal to, factor out 2. 2 divided by 2 is 1, plus or minus 2 root 3i divided by 2 is root 3i all over 2. Now see that 2 cancels out 2, right? Leaving the value of x to be equal to 1 plus or minus the square root of 3i. So there are actually 2 values of x from here. So the fifth value of x from our solution is equal to 1. Go with the positive plus the square root of 3i. And the last one is, which is the sixth value, is 1. Going with the negative root 3i. Very good. So 6 values of x in total. There are actually 2 real solutions. So the first one is 2 and negative 2. These are the real solutions. So this is the third, okay, this is supposed to be the fourth value, 2 and negative 2. Then the second value that we got is negative 1 plus root 3 times I. Now the third value that we got is negative 1 minus 3 root 3i. Then the fourth value, oh, the fourth value is already there. The fifth value is 1 plus root 3i. And then the last value is 1 minus root 3i. So these are complex solutions, while these are real solutions. So these are real and these are complex. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.